Hi, what is strange attractor? A strange attractor is an attracting set of unstable trajectories in the phase space of dissipative dynamic system. You can read more about the term at the link in the description. You will also find a link to Behance with examples of different attractors. Here are the equations and values for each type. In this tutorial we will create a Dequan Li Attractor in Unreal Engine Niagara. The system consists of two emitters. The first one defines the trajectory, the second one creates a ribbon based on the first one. Let's start. Create a system. Open it and create an emitter. Call it source. Turn on local space. Turn on infinite loop in emitter update. Leave everything else unchanged in the rest of the stack. Turn on infinite life of particles in particle state. To reproduce the equations we have several ways, but I will show you the fastest and most convenient way. Create a scratchpad, create float variables for each parameter of the equations. Also create a vector variable and call it position. Create a HLSL node and connect the variable to it. And rename position to pose. In map set variable velocity. And connect the output of HLSL node to velocity. Also rename it to onPose. At the beginning we set the values of onPose to pose. And convert the pose vector to float format. Then we set variables for each coordinate based on the attracting equations. In a nutshell, we take the position of particles and send the next position for it based on the equations. And we don't use dt variable, because we use velocity instead of position, and Solver will do this for us. We override the variable and post in vector format from float variables dx, dy, dz. Press apply and go back to graph Niagara. Now let's input the values of the equations for the attractor. Translate position to vector and select particle position. The attractor is ready. From this step you can experiment with system parameters and what it will look like. But first, let's start by repeating the example from the beginning of the tutorial. Add solve force and velocity, and set speed limits so the particles won't fly around too much. Set spawn the particles from the grid. and set the number of particles. Also set the space between the particles. We can already see the attractor shape. Create a second emitter and call it ribbon. Set the emitter state to self. And add the sampling of particles from the other emitter. Set the name of emitter's source. And change the spawn rate. Don't change anything in the rest of the stack. Create ribbon render. Change the shape to tube. Turn on accurate geometry. Increase subdivisions. Turn on custom mode. And use constant factor to make the tessellation of the ribbon smoother. Add material to the ribbon. I took a preset of aluminum from the Megascans library. Set the size of the ribbon to decrease as the particle age. And initialize particles, we set the size of the ribbon. Find the best value for it. Add a light render to the source emitter. Set the radius and color sampling. In particle blade we create scale color and high value. This parameter is responsible for the brightness of light source. At initialize particles, we set color for light source. Here we have repeated the example from the beginning of the tutorial. If you enjoyed this tutorial, don't forget to subscribe to the channel and like the video. Thanks for watching!